Okay, so today we are moving into arcs and chords, and what we've been talking about is central angles. And when we have a central angle, what we have is that angle that is in the center of your circle. So just as a refresher before we jump into arcs and chords, is that our central angle would be there, and then our arc would be the same measure. Remember that an arc is a curved portion on the circle, and a chord is going to be a segment that goes through the circle that has two endpoints on the circle like you see right here. So we would call this chord AB. So when we talk about chords, we have three different theorems that we're going to look at, and they're going to form different shapes like quadrilaterals and triangles and all of that kind of stuff. So looking at the first theorem we have today, it says in a circle, or you could have two congruent circles, then you have two minor arcs that are congruent if and only if their corresponding chords are congruent. So if we put some letters on the circle here, we're going to say we've got A, B, C, and D. And we see that right now we've got chord AB and chord DC that are equal because they're marked with these 1 dash marks on each side. So if we say that both of those lengths are 5, then what they're saying is then this arc and this arc would be the same length, would be the same measure. So if this is 60 degrees, then this arc would also be 60 degrees. So what you need to write is if segment AB is congruent to segment CD, then we know that arc AB is congruent to arc CD. So on the inside of this foldable, we're going to look at two examples. So on this first example, we know it says if AB equals 5x, and that would be talking about this segment right here is 5x, and CD is 3x plus 6, that would be this segment right here. They want us to find the length of AB and the length of CD. We know that arc CD is 127 and arc AB is 127. So if the arcs are equal, then the segments have to be equal. So we would set up our problem as 5x equals 3x plus 6. Okay, then you know how to solve. We would just subtract 3x on both sides and get 2x equals 6. Divide by 2 and x equals 3. Now we're not done because they want the actual length of arc AB and the length of CD. So we would just need to plug those in. So we would say AB equals 5 times 3, which equals 15. And segment CD is 3 times 3 plus 6. So 9 plus 6 also gives us 15. And those would be your final answer. Looking at our second one, we have a little bit different because now we have a quadrilateral inside of our circle. And we know that this arc is 150, this arc is 50, this arc is 80, and this arc is 80. So if this arc is 80 and this arc is 80, then we know that their corresponding segments would also be equal. So we can set up our problem as 12x minus 2 equals 34 because of those arcs being congruent. Now again, we're just solving. We're going to add 2. 12x equals 36. Divide by 12. And you end up with x equals 3. Now in this problem, they just asked us to find the value of x, so that's all we have to do. So our first theorem is done. If the arcs are equal, then the chords are equal. Okay, so the arcs are equal, so the chords are equal, so now we're moving on to the second theorem. The second theorem says that in a circle, if a diameter or a radius is perpendicular to a chord, then it bisects the chord and its arc. Okay, remember that a diameter and a radius have to go through the center point. Okay, and we're going to call our center point on this circle point C. Okay, I'm going to go ahead and add in a few more letters here. We're going to say L, M, N, and we're going to call this point P. So what we're looking at here is that if we have a radius or a diameter, now in this case we have a radius, and our radius would be segment CM. Okay, so we know we have a radius, and we're looking at, is it perpendicular to the chord? Now our chord on this picture has two endpoints on the circle, and that would be segment LN. And we see that we have this nice 90-degree marking at point P, which means that these are perpendicular. So we would say that CM is perpendicular, that upside down T, to segment LN. So if those are perpendicular, then we know that this segment, the chord, is bisected in half, to where we would have LP is congruent to PN. Now what you have to be careful here is that we see that CP is not equal to MP. Okay, the other thing that we would know is that our arcs are also going to be congruent. So arc LM would equal arc MN. So we would have arc LM is congruent to arc MN. So we are going to look at some examples based off of that. So looking at this first example, we have to be very careful about how they worded the information that they gave us. Okay, given that chord BC is 15 centimeters from the center. Okay, if this is the center, this is chord BC, then it's 15 centimeters from the center, so 15 would go right there. Okay, then it's from the center of circle A, which has a radius of 25 centimeters. Okay, now when we have a radius, our radius goes from the center to the edge of the circle. So AB could be a radius, but we also have AE that is also a radius, so we know AE also equals 25. Now they want us to find BC and DE. So first we're going to call BC X and we're going to call DE Y. Okay, so DE is this part right here, which is Y, and BC would be this whole length, which we would call X. Okay, before we can find BC, we're going to have to find a piece of that, and our piece would be BD. Now in this picture, we know we have this right angle, which means that BD and DC are going to be equal to each other because they're bisected. Okay, so to find BD, we're going to use the Pythagorean theorem. Now, Pythagorean theorem, a squared plus b squared equals c squared, but in this case we have our c, so we're going to subtract. 25 squared minus 15 squared equals, I'm just going to call it a squared. Okay, let's call this part a. So 25 squared gives us 625. 15 squared is 225. When you subtract those, you get 400. And then you've got the square root of 400, which is just 20. Okay, so we know BD is 20, which means to find X, or BC, then we just need to say 20 times 2, which is 40. Okay? Then that other piece is a lot easier to find. To find DE, we know that this whole thing, AE, is 25. Okay? Then we know that AD is 15. So to find DE, we just subtract and you would get 10. So those are your two answers on that one. Number 4 is a little bit different because now they gave us some different angles on number 4. Okay, so if we're looking at number 4, we know that we've got a 60-degree angle, we've got a 90-degree angle, which automatically tells us that at angle A we're going to have a 30-degree angle. Okay, now what we're looking at here is we are trying to find AD, which I'm going to call X. We're trying to find CD, which we're going to call Y. And then they want the measure of arc AB, which is going to be from here to here. Okay, so let's deal with x and y first. If you'll remember when we had a 30, 60, 90 triangle a while ago, we have 90, we have 30, and we have 60, that we can use our boxes. Okay, we know this part is 6, and our boxes are going to be m, 2m, and m square roots of 3. Now, we are starting off with our 6, which is across from 90, and if you'll remember that our 2m is across from 90, so we're going to put 6 in that box. To go from 2m to m, we're going to divide by 2, where we get 3, and then to go from m to m square roots of 3, we're multiplying times the square root of 3, where we would get 3 square roots of 3. Then we have to say what's across from 30 and what's across from 60. So across from 30 is our m, which is our y value, so we're going to say y equals 3. And then our across from 60 is our x, which equals 3 square roots of 3. So our y is our CD length, and our x is our AD length. Now, when we've got arc AB, we are finding the measure of that arc. Okay, this is where our central angles come into play. So we know this angle is 60 degrees, which means the arc would also be 60 degrees. So if this arc is 60, we know these pieces are equal. So these pieces are equal. So to find the measure of arc AB, we would just add 60 plus 60 to get 120 degrees. So a little more triangle involvement when we are dealing with this second theorem, but not too bad. Okay, our last one, we are still going to have triangles. And this theorem says in a circle or congruent circles that two chords are congruent if and only if they're equidistant from the center. Okay, so if they're the same distance from the center point, then the chords are equal. So, putting points one more time here, we've got A, B, C, and D. And let's call our center point O. We know that this segment and this segment are equal because they already put those dash marks there for us. So let's say those were 7, then they would be the same length, and that would mean they are equidistant, which would mean that this segment and this segment are going to be equal. Okay, so if these pieces are equal, then AB is congruent to CD. Okay, so if we're looking at example number 5, it says in circle A we know that FG is 3 and GA is 5 and AH is 4. Find the length of PJ and LA. Before we can go and find this length and this length, we have to figure out if those chords are equidistant from the center. Okay, now if this is 5 and this is 4, then we know we can find this length by doing Pythagorean theorem. So we would say 5 squared minus 4 squared equals x squared. 25 minus 16 equals x squared. 9 equals x squared. Take the square root. And 3 equals x. So these pieces are equidistant from the center, which therefore means that they're going to be equal. Now, the other part that we have here technically is that GA is a radius, is 5. So PG is 5, which obviously means that PF would be 4. Now, the part that you have to factor in is what if we drew in this triangle? Okay, that GJ would still be 5, which obviously means that JF would have to be 4. So to find PJ, we would say 4 plus 4, which gives us 8. And we know that PJ and LA are equal, so then LA also has to equal 8. Number 6 is more what you're going to see on a regular basis. Here we know that LA is 2 and AP is 2, which means that chords JH and GF are equal. So FG is 3x minus 4. HJ is 14. And we know that FG is equal to HJ, where we have 3x minus 4 equals 14. And you just solve for x by adding 4 and dividing by 3 to get x equals 6. Okay. So arcs and chords is all about using those triangles to find what we know is congruent. If you needed more help, make sure you come and see me. And I hope this was helpful.